Welcome everyone to our alumni webinar, and we're thrilled to have you here. My name is Tom Pico, and I'm the President and CEO for the UMaine Alumni Association. We are excited to continue our periodic webinars for you all to reach UMaine alumni near and far with updates on a variety of topics from the University of Maine. And of course, today we're excited to share with you more about the Maine College of Engineering and Computing, and we'll be getting to that program in just one second. That the Maine College of Engineering and Computing, as you probably know, was launched in April, and we're thrilled to have Dean Giovanna Guidoboni with us, and we'll hear from her shortly. Before we do that, we are thrilled to have President Joan Farini-Mundy with us to give a brief welcome. President Farini-Mundy, as you probably know, has been the president of the University of Maine since July of 2018, as well as the UMaine at Machias campus, and since 2021 has served the UMaine system as Vice Chancellor for Research and Innovation. President Farini-Mundy, thank you for joining us today.
Thank you for having me, Tom. Good morning, everyone, or good afternoon, I guess now. It's a pleasure to be able to be with you and to say a few words before you hear from Dean Guidoboni about how excited we are at the University of Maine about many things, really, including the innovations that will occur through the new Maine College of Engineering and Computing. First, though, I'd like to welcome all of you. I'm kind of scrolling through the list as people are coming onto the call, and it's great to see so many wonderful alums and supporters and people interested in the University of Maine attending this webinar. I'd like to thank the Alumni Association for hosting these wonderful educational sessions, great chances to dig a little more deeply into all the good things that are happening at the University of Maine, which, by the way, I would add baseball. This one isn't about baseball, but take a look at our America East champions and watch for them as they move through the next phases of the league championships. So very excited to be here with you all. The Maine College of Engineering, which Dean Guidoboni will describe in much more detail, is an exciting piece of the overall UMS TRANSFORMS project, the $240 million investment by the Harold Alfond Foundation in the University of Maine System. And that innovation, the innovation that is made possible by UMS TRANSFORMS will indeed transform our system and our university. We are very fortunate to have a leading role in the portion that you're going to hear about today, which is it began really with discussions about the engineering needs in the state of Maine and the workforce needs, the importance of filling positions across our state, but to fill them in a way that anticipates the future, that expects and looks at what it will take to be a successful engineer in a very rapidly changing technological environment. So you'll hear about our ideas there, but at the same time, we have recognized the importance of computing and the various areas of computer science and how those belong also in this category of areas where the University of Maine System needs to be supplying a workforce for the future. So the Maine College of Engineering and Computing brings the two fields together within a college. It will build on the great strength of the University of Maine College of Engineering, as well as the University of Maine School of Computing and Information Science, and our partners at the University of Southern Maine in their departments of engineering. So a chance to really envision the future. Giovanna will tell you about all the great ideas that are bubbling right now, and what we'll be looking for over the coming years will be your involvement, your reaction, your thoughts about how we become the place in the entire University of Maine system to move engineering and computing forward. So again, thank you for being here today. I'll pull back and turn this back over to Tom.
Thank you very much, Joan, for being with us today. We appreciate it. Before we turn to Dean Guidoboni, a couple of housekeeping notes I wanted to share with you. First, I wanted to make sure that everyone is aware that we are recording this session, and we'll be sharing this later on our YouTube channel for those who were unable to join us live today, but wanted to make sure that you are aware of that. Secondly, we will have time for a few questions at the end of the session before we wrap up at 1 o'clock. And if you'd like to submit a question, please send that in the chat to the Zoom host, who is Nicolette Hashi from the Alumni Association, and she will relay those to me to ask at the end. We'll get to as many questions as we can with the time we have available. Now I'm pleased to introduce Giovanna Guidoboni, who is the inaugural Dean of the Maine College of Engineering and Computing. This college bridges engineering and computing programs for the benefit of all students across the University of Maine system. She previously served as Associate Dean for Research and Professor in the College of Engineering at the University of Missouri, and is founder and manager of GSpace LLC, which provides modeling and computational solutions for complex problems in engineering and life sciences. Dean Guidoboni also serves as co-founder and co-editor-in-chief of the Journal of Modeling and Artificial Intelligence in Ophthalmology. She holds a doctorate in mathematics and both a bachelor's and master's degree in materials engineering from the University of Ferrara. Giovanna, thank you so much for taking the time to be with us today and to share with our alumni and friends.
Thank you so much for the nice introduction and for the opportunity to share with you the amazing things that are happening at the University of Maine and across the system. So I'm going to share the screen. Can everybody see?
We see it.
Okay, perfect. So MCEC, the Maine College of Engineering and Computing. It was born on April 1st, 2023. And it is really stemming from an amazing vision that the president just introduced for us to really bridge engineering and computing disciplines across the board, really, meaning that even engineering and computing per se are really embracing a number of disciplines. For example, if we think in engineering, we go from civil engineering to mechanical engineering and so on. And computing also has many aspects: computer science, information science, scientific computing. And so the Maine College of Engineering and Computing really aims at drawing from the natural synergies from these two big fields to actually be able to graduate the workforce that is needed to innovate our future, especially in the state of Maine and in the region. But actually, I hope I will convince you that really the innovation that is happening here, also at the level of structure of the whole university system, will really be leading the innovation nationwide. So I have really the privilege to be the inaugural dean of this college. I joined the University of Maine on January 1st, but I would like to spend just a few slides on really sharing with you how I came here and why I'm really so excited about this vision. So really, there is the need. So that there is the need for a workforce that can really bridge engineering and computing is a fact. So here you see some data coming from the Bureau of Labor, and this shows you how the growth is projected to be for the engineering and computing occupations in the state of Maine, which is the trend in orange, with respect to all other occupations. And we are currently not graduating enough people who can take this job. And I will address the question also as to why that may be as we go forward. So I would like to, as I said, take just few slides to share with you who I am, how I got here, and again, why I am so excited and passionate about this vision. So as you can imagine from my accent and from my name, I am from Italy, from a small village called Casumaro in Emilia-Romagna, a region that unfortunately now has been really subject to very extreme weather and flooding, and so brings up the importance of addressing climate change and also making sure that engineering and computing can help address that too. But anyway, so I come from a small village and I have studied at the University of Ferrara, a nice city with the moat, the castle, the walls. It was just 20 minutes away by car. So basically I grew up in this kind of small village context, knowing everyone, the sense of community. So even though I am not from Maine, I truly relate to that sense of family and community that really comes with making really the need and kind of the innate motivation to try to make an impact in the region where you are. I studied, as I said, at the University of Ferrara, and I studied engineering in my bachelor and master. And what I really liked about solving problems was that I could, if I would be to use mathematics and numerical simulations, I could use things that were beneficial, for example, in civil engineering to actually build buildings, to help medical doctors understanding, for example, the function of our skeleton in the body that has a similar kind of structural function. So I really liked, my personal passion was about using mathematics and modeling to draw solutions from different fields to then advance everything I really wanted. And actually, this choice, the choice to pursue a PhD in mathematics after a degree in engineering in the same university I graduated from, very close to my village, made it impossible for me to pursue an academic career in Italy, because I was not a typical engineer anymore, and I would never be considered a true mathematician because I started from engineering. So that was the first time I really faced the reality of the need of interdisciplinarity to really be more effective in problem solving, and at the same time, kind of an academic structure that was somewhat siloed and was not really changing at the same speed as the needs that were perceived in the world. So after 28 years, I actually left my village. And so this is just to explain to you how passionate I am about the need of actually bridging disciplines together. So after 3 months in England and 6 months in the US, thanks to a Fulbright fellowship, I actually was hired at the University of Houston because I had both a background in engineering and mathematics. So all of a sudden, it actually became a plus. But after that, so I moved around. So I was in Indianapolis for 5 years, and then I went to France for 3 years, and then at the University of Missouri for other 5 years, and then at the University of Maine. So of course you can ask, oh, why did she move around so much? Well, life is made of many things, including having a family and having to juggle many things at the same time. And I always, remind this to my students, to administrators, everyone. When we talk about numbers and trying to increase the graduates, increase the enrollment, hire more faculty, what we are talking about really is people. People with families, people who we would really like to excite as much as we are about our vision, our mission, so much that they decide to invest their lives on us. And so you will hear from me vision about the spaces, the programs, how we can excite more our young minds to pursue a career in engineering and computing. But really, we should think more broadly, and how can we make it easier for family and people, to live here in terms of childcare, healthcare, and so on. So that may be kind of right now out of my realm of impact right away, but I think that as a community, we should really keep that in mind. And before I move forward, I also want to tell you that the University of Maine System is not the first university system I am part of. So as you see here, I was in Indiana University, Purdue University, Indianapolis. The campus was in Indianapolis, and it was a very strange arrangement. I was receiving a paycheck from Indiana University, and I was granting Purdue degrees. So every time I wanted to make a change, like for example, in a course that I wanted to offer or something like that, I had to kind of have two systems to agree, which was pretty complicated. And so many times, I was feeling, is the system working with us or against us? What is really the role of a system? Then when I was at the University of Missouri, I was at the flagship campus in Columbia. And this was really the first place who hired me both as an engineer and a mathematician. My appointment was split 60-50 between the two. And when I was serving in my role as Associate Dean for Research, I maintained this split with actually the goal of building bridges across colleges and across disciplines. And yet we were part of a system. We were in the flagship campus, but the true collaborations and across the campuses of the system were pretty limited. And so when I read about the vision of the Maine College of Engineering and Computing at the University of Maine, having really the vision of, and now I move again to the next page, which was actually the first slide, the vision of truly working across the system and leveraging the strengths and the differences of the focuses of the various campuses for the benefits of all the students across the system. And the intentional vision to actually bridge engineering and computing, I thought, finally a place that is really looking at the system per se, and how system, I mean academic structure, infrastructure, and environment, and how can we look at it and make changes that are really necessary to enable us shaping the workforce of the future. I have not been everywhere, but I have been in many places, and there are really not many places who are willing to really take on these difficult conversations. A friend of mine from another university told me, Giovanna, this is really like mind-blowing. Oftentimes, he was saying, I perceive academia as like sports, like you are recruited and you are expected to give your best and perform, the best out there in the field, but you are not supposed to change the rules of the game. It made me think, even in sports, of course, it is possible. In my youth, I was playing volleyball, and the rules of the game when I played it are very different from what they are right now. So many times it is just because things have been done in the same way for so long, then, change is perceived as something difficult or not so easy to approach. But again, here what we are looking at is a change that does not wipe out what has been built, but really builds on the strengths, again, as we will go through, of the various campuses, of the tremendous legacy of the College of Engineering at UMaine, and kind of help, the goal is really to make them converge and to build something which can achieve a much broader impact across the state, across the region, and across the US. So having said that, what are the goals of the college? So here I listed 4 of them, but really each of them has a lot of implications. I already talked about the first one. If any of you has been in engineering for a while, or even anywhere, the advances of technologies have changed a lot how we do things. If we think, for example, how many things now are happening on a smartphone that before were happening just on pen and paper, really emphasize the need of bridging the advances in engineering with the advances in computing, so that the two fields can really open possibilities that were not there before. Also, our goal is to increase the number of graduates. Why do we want to do that? Well, we just saw the slide on how much really the demand is out there for graduates in engineering and computing. However, in order to achieve that, I truly believe that we need to inspire the young minds. And when I say K-12 in the point 3, I think that many people who are in high school kind of already made up their minds. I may be biased by the fact that I have a middle schooler and a high schooler, but I truly believe that it is our mission and responsibility to engage young minds, especially at the elementary and the middle school, and of course continue through high school, and try to have them envision what being an engineer or a computer scientist could be, and how they could impact the world by undertaking these studies. The university and the university system are already doing a lot of activities in this regard. Like, for example, I was just there at the Windstorm Challenge that we hosted. It had more than 600 high school kids participating in really a year-long activity on designing a platform to support the offshore wind structures. And this is just an example, but we really need to bring this experience and this excitement inside the classrooms and help the teachers, support the teachers who actually see our kids for a very long time during the week and help them see how really engineering, bottom line, is problem solving, is critical thinking. And when you combine all the disciplines and bring in computing, for example, you basically have more tools in your toolbox to actually design effective solutions. And of course, it is very important to bridge and to build a strong partnership with industry for various reasons. So innovations, in order to have an impact, needs to become a reality, needs to become jobs, needs to become products that really impact our everyday life. And I think that connection between the creative thinking that occurs in academia and the translation of that into something tangible in industry is also our responsibility. So if we take a look at the goals, these are really broad and they could feel overwhelming, but they are really not if we think of them as goals that we can achieve as a system, as a team, leveraging our strengths. So what is our vision? So I said so much about the changing world, the need to breed disciplines. And so basically we need to understand that the people that we are graduating today will go into the workforce for jobs that will require knowledge that is not even conceivable today. Like, again, when I graduated in engineering, I had only a friend who had a cell phone and of course it was not a smartphone. So things are changing and really, really fast. So we need to think that the kind of education that we give is not such that degree is that flag that you plant on the top of the mountain, kind of, I'm done, check the box. The degree is not the destination. So really, degree, I envision it like the runway of an airplane. So we need to really prepare our students to take off and go wherever they want to go. And maybe they will engage in different careers and their life will take different paths. Like, for example, it occurred to me, but if we teach them how to learn and how to have strong foundations on which they then can build, and be responsive also to the needs and the societal problems that need to be addressed, then we will be truly better off, not only as a university, but really as a society. So how do we, I have this slide because I usually show it to my students. What are examples of the fact that an engineer and education in engineering and computing can really take you anywhere? Of course, I mean, the image here says the world, but at least I have experienced in my own career that even if I started understanding the basic principles of, for example, building a house that has a structure like the walls, and then different pipes that take different kind of fluids, for example, hot water, cold water, clean water, wastewater, all the engineering principles that you develop, for example, in civil engineering, with the help of computing to actually simulate and design a construction, they can actually be applied also to understand the human body. And that is also what I do in my research. I study the cardiovascular system and also how changes, for example, in blood pressure affect vision and the eye, and how to develop sensors to monitor cardiovascular function. And how I did that, even though I do not have a training in medicine, I do not have a training in biomedical engineering, but I have strong foundations in the principles of engineering and computing. And then this allows really the transfer of knowledge from, for example, a house that has a structural component like the walls and the roof, which is what our skeleton is doing. The different pipes where different types of fluids are flowing. It is similar to our body where we have arteries and veins and so on. And interestingly, if we enable our students during their degrees to at least be open to these connections, that is also where we can leverage solutions that nature has already developed to solve some of our problems in engineering, like, for example, self-healing asphalts. They come from how we heal wounds in the body. So, and other examples of these connections are, well, I just show you everything. Like some non-trivial connections are, for example, I told you that I study the eye and for example, the production of aqueous humor in the eye. And pretty interestingly, the same equation and the same physical principles that govern the aqueous humor dynamics in the eye are those that describe the charges and the currents in a semiconductor. So again, my view really for the college is to create an academic environment that really allows our graduates to have strong technical skills in whatever field or subdiscipline they find to be more passionate about, but at the same time, be aware of where their skill set could be useful for, and not just like in a box. And even if, for example, they are not particularly keen in computing per se, they prefer someone else to do that. But if they have at least some exposure to it, they know who to call, which kind of skill sets they need, and how to combine them. So this vision really, how does this translate in what we do? So indeed, it is important that our graduates have a broad skill set. So I already talked about the technical skills. And actually, the more people I meet in industry and alumni, the more I hear about how everyone enjoys hiring our graduates because they are very strong technically, and they are also open to teamwork. Of course, this makes me extremely happy and proud. And we are, I hope you're happy to hear that we are continuing to go in that direction even stronger. And as you will see, as we are going through our physical spaces, we are looking at how can we renovate them so that we can make them home, natural home of teamwork, critical thinking, and the kind of collision across disciplines. It is also very important that such exposure to different disciplines does not happen only towards the last years, because really sometimes there is the feeling that you begin with, those courses that you have to take, maybe more kind of core courses in math and physics that are somehow disconnected from the real passion, and then the real passion comes towards the end. Because we are an R1 institution and research is really one of the missions here, we have the opportunity to engage our students within our labs to get activities as well as credentials and certificates across disciplines. And so one thing that we are now doing in a very intentional way is reviewing all what we are offering and how can we make sure that our students are exposed to this fervent interdisciplinary environment from year one. That would also be extremely important for retention and to make sure that students have a kind of a peer network that they can rely on, not only from the academic viewpoint, but really as a more kind of round academic experience. Also, as I am meeting more and more people also in industry, it is becoming more and more clear that not only we have a mission to kind of nurture and graduate, fresh high school students, but also it is very important that we provide opportunities for people who are already in industry and would like to deepen or acquire more knowledge in certain fields, because as we said at the beginning, engineering is continuously changing, and maybe some of the skill sets that are necessary now were not really taught even a decade ago. And so as, again, a university system, we are uniquely positioned to fill those needs also. And because of that, we are really called to look at various learning options, going from remote, in-person, hybrid, asynchronous, and I guess the pandemic has taught us all that we can do things in many different ways, and we can really use them to our advantage. And this is extremely important also as we move to work more and more as a system. So the University of Maine has several campuses, as you know, located in different locations. And our goal is also to use for example, the research facilities that we have at the University of Maine to populate with data and courses, degrees that are happening also in the other campuses and vice versa. So thanks to the unified accreditation across the University of Maine system, we have already kind of an infrastructure that is ready for us to make sure that across the system, we developed opportunities for learning that are really complementary, and that I really would hope that our students across the system feel that they have at their, at their doorstep opportunities within the campus where they are, but also across the system. So we already have several of these things in place, like, for example, the Maine engineering pathway that allows students starting in different campuses to then complete their engineering degree at the University of Maine in Orono or at USM. But we are developing more and more of those, and I will tell you a little bit about that. And most importantly, it is, for me, it is, and for all of us, it is truly important that we create an environment that is welcoming and supporting. So it is building a community as much as, shaping graduates that are strong technically, because ultimately, I think that our responsibility and our mission as an academic institution, as people, we want to mentor and grow the new generation of the workforce, which will have a positive impact, which will help us make the world a better place for us and for the next generations. And again, that can happen only if we have our eyes open on how diverse our world is, and also acknowledging that certain engineering solutions, for example, that may work in certain countries may not work in other countries, or within the same country may not work the same way in a urban setting or in a rural setting. So again, being welcoming and supporting and open to diversity is important, both on a kind of personal social level, as well as to really achieve effective engineering solutions. So I plan to talk maybe for other 5 minutes or so that we can have a conversation, really, because as we are shaping the vision for the college, I would truly welcome any input or suggestion or comment that you have. And by the way, if the time runs out in this hour that we are given, I would welcome your input, suggestion, and comments even after that. So the way in which I see it, in the sense, how can we build this new college? I see 3 main components here: space, academic and research programs, and overall experience. So what do I mean by that? What do I mean by that? So academic and research programs, to me, these are kind of the degree opportunities or certificates or, kind of the content that we can offer. And indeed, not only our goal is to continue and to make even stronger the existing programs in engineering and computing at UMaine as well as across the system, but also to enable, as I said, students across the system to benefit from courses, labs, whatever learning opportunities that are available across the system. So I already mentioned the Maine engineering pathway. I am also very happy to mention that we are actively working and kind of very close to the approval process of degree programs that we call 4+1 or 4+2 that basically will enable students right now in electrical engineering at the University of Southern Maine to basically complete their degree, their bachelor degree with a master at the University of Maine, just taking few more courses. So I like this example very much because this is an example of kind of academic pathway that, again, plays to the strengths of the institutions. So for various reasons, students may prefer to attend engineering at the University of Southern Maine or the University of Maine, and at the same time, completing a master with their studies wherever they started, leveraging, again, for example, the upper level courses or the research opportunities that are available at the University of Maine are really benefiting the students at both institutions. And more of these kind of programs are coming along as we take an intentional review of all of our programs across the system. But I also have a small box here saying new. There are several opportunities for us to really capitalize on the bridging of engineering and computing beyond the existing programs. For example, there are some cross-cutting opportunities, for example, exploring modeling and simulation engineering that would have impact really from civil to biomedical to environmental engineering. That could be an option, as well as leveraging a lot of the innovation in terms of advanced manufacturing and material science that is going on. So these new programs are currently under discussion, and of course, this conversation will continue in the decades to come. When I talk about overall experience, I am thinking that as we develop these programs, we have to keep in mind that the audience that we should engage is pretty diverse. So I am thinking not only at faculty and students that are at the University of Maine, but also those that are at the University of Southern Maine, as well as across the system. But in addition to that, we need to think broader. We need to think, how can we engage the community and our K-12 kids so that we kind of, as I said, excite potential students to actually pursue a career in engineering and computing. Too many times, and again, maybe I talk about personal experience, but too many times students are kind of turned away from engineering because it is difficult for them to kind of think within the box. I have one of those at home who loves to build, but she loves to break the rules. And as soon as, for example, you give a math rule, the first thing she thinks is, how can I go around it? And so this is not the typical kind of engineer that you would think of, but actually it is extremely important to think that way if you really want to like troubleshoot or to, think at everything that can go wrong so that you can prevent that. So what I'm saying is that I think that like, as we are all different, there are different hooks that can entice people to envision at least themselves of what being an engineer or a computer scientist could be. And I think that as a community, we could really engage intentionally with our K-12 population and excite them about these careers. Of course, I already mentioned industry, and that was one of the first slides, the needs to actually support our industry with the workforce of the future, and a continuing conversation about what the needs are that will really also enable us to make our programs stronger and our graduates more competitive in the market. Nothing of these things can happen without looking at the space that we have. Because that is where our students, spend their time. So indeed, it is important to think what we teach and what programs we enable, but also where we do it and how we do it. So I have few examples. This color code means that I have been extremely lucky and privileged and honored to inherit basically the new building, the Furland Engineering, Education and Design Center, which is truly amazing, as I have few pictures in the next slides. And I am also very excited to be part of the design of a new building that will enable things that are not possible now. At the same time, we have other buildings and this is not an exhaustive list, that really needs renovation, not only in structural terms, but also in what the spaces can enable. So this is what I mean. So the Furlan Engineering Education and Design Center was inaugurated on August 2022. I hope that many of you have toured the building. It is truly amazing. That was one of the first things I also showed my family, even before coming here. And what I truly like about the building, it is that it is welcoming, it is colorful, it is full of light, and it enables really collaboration and teamwork, while also enabling, learning and teaching. So, for example, if you have walked through the first floor, you for sure will have seen the project design suite. That I have actually pictures here where our students can work on their capstones, and this is really one of my favorite places. I have toured it many times to show it to different constituencies. And for example, one day there was a group of students working on a drone. And so I asked them, does it fly? And they said, well, yesterday it did. And I was like, what happened? And so they were showing me how they flew it, but one of the motors fried, basically. And they were like, but we really think it has been because we designed the blades to be too heavy for the power of the motors. So now we are redesigning them. So, and they were very excited, and they went on and on how they were going to fix it. So what I'm trying to say is that this space, so the fact that students can work together at the tables, the machine shops that are surrounding the space where students can actually go and get parts. So this space has enabled a way of learning that is not possible in the traditional buildings. And in particular, the possibility to fail and learn from the mistakes so that whatever can converge in finding a solution. So this is a completely different way of learning from learning to pass a test, because in that context, basically failure is really, really a bad thing. You should not fail, because everything counts towards the grade. Whereas when we think of projects and capstones and moments like that in the education, basically we are embracing that actually when you try, you may fail. But the important thing is that you don't stop there. You try to understand why, and that makes you a much stronger person, a stronger engineer, a stronger computer scientist. Overall, it makes you a problem solver and kind of enables you to bring in all the, as I said, the critical thinking and maybe also connecting disciplines. For example, I heard from other students how being in the same space, mechanical engineers and also people in biomedical engineering, sometimes they ask suggestions or help, which is actually what is happening in the real world. So this is an example of how Furlan and Boardman look like. So it is a very different space that actually gives you a very different opportunity for learning. So the way in which we are looking at our buildings is really how can we not only renovate them so that the structural, mechanical, and electrical parts, are up to code and so on, but how can we intentionally make the spaces suitable for a workforce that we want to train in a way that is technically strong, but also encourages collaboration and communication. Finally, I want to talk about the GEM building and the overall GEM initiative, which was one of those that I mentioned in the space. So this is, in my opinion, a true example of how the convergence of engineering and computing can really help us change the way in which we think about manufacturing, about really creating products of different types. So the idea of GEM, which means Green Engineering and Materials, is to think of manufacturing in ways as, for example, you can 3D print your object. I'm sure you have heard or seen the 3D printed home and the 3D printed boat, which is pretty exciting, but how do we go there? So in order to do that, you see here drones and sensing and data that are kind of acquired while you print this. And so to actually enable this kind of innovation, you need to have a workforce that understands manufacturing, that understands sensing, understands how to analyze the data, how to design the robots here for the printing so that they don't clog when you put new materials. So we don't have right now a degree program that has this convergence of disciplines. And by the way, no one in the world has it. And so when I mention new programs, along with the new space, what we are thinking of, again, is how can we intentionally enable the convergence of disciplines in ways that really our graduates will be a leading example in the US and in the world of what convergent disciplines actually mean. So this is really my last slide, which is we have a need, we have a vision which is pretty broad, and we started. So we are truly on our way, and we cannot do it without really working together. And you as alumni really play a very important role, connecting all the dots with the community, the graduates, the industry, and you have a vision that is much, and a knowledge that is much broader than the one I have. And so I truly welcome, as I said, your inputs, ideas, and suggestions, both in this talk and beyond. So thank you for the opportunity to share this exciting time, and I'm looking forward to hearing from you.
Great, Giovanna. Thank you very much for that terrific presentation. Perhaps you could unshare your screen, Giovanna, so we can, there we go. So super. I just want to remind folks that if you have questions for Giovanna, you can submit them in the chat to Nicolette Hashi, who is managing the Zoom for us from the Alumni Association. I also, while you're thinking of questions, I wanted to acknowledge that we do have Grace Garland with us too, who is the project manager for UMS TRANSFORMS. Of course, the Maine College of Engineering and Computing is a key pillar of the UMS TRANSFORMS plan, which really is driven by the $240 million gift from the Harold Alfond Foundation. So Grace, thank you for being with us. I don't know if you had anything briefly you wanted to add at this point, but while folks are thinking of questions, I wanted to give you an opportunity to say hello at least. So.
Thanks, Tom, and hello, everyone. No, Giovanna did a brilliant job of speaking about the Maine College of Engineering and Computing, which we are all tremendously excited about, is one of the 4 signature initiatives of UMS TRANSFORMS, along with student success and retention, UMaine Athletics, and the Maine Graduate Professional Center down here at 300 4th Street, which I know you've all visited fairly recently. So thank you, and thank you to Giovanna for this terrific webinar.
Great, thank you, Grace. So Grace can chime in too as we have questions come in. But Giovanna, I had one just from me. I wanted to. You've obviously been to several universities in your career and in your studies, and I'm not sure that the general public in Maine quite fathoms how fortunate we are to have the facilities and the programs that you've just described here. Can you just put this in context for us in terms of a rural state like Maine and the facilities and programs we have and how that might compare to other places? Definitely,
because really for me, it has been a wow factor. So I would say first kind of a comparison US Europe, as I have been in several places in Europe. So the type of like the US in general has facilities for really experimental labs and research centers that are just not comparable to what students in Europe have available when they study engineering. So I think that in general, engineering is not just one thing across the world. So in Europe, there is a much more kind of theoretical approach to it. And in the US, it is more hands-on. Of course, it is a kind of broad comparison that is not true everywhere. But then it is also, what is it that it is available kind of to do, your experiments hands-on. So when I was at the university, Indiana University, the labs were really kind of limited, and it was mostly like labs of professors. There were only few research centers. And at the University of Missouri, they started to invest heavily on having buildings and labs that could really enable the convergence of disciplines. But just to give you an idea, like there was one building inaugurated also 2021 or 2022, that it took several years to become a reality, and it was actually related to translational sciences in the life sciences realm. And really took a lot of work because, again, people would not, it was difficult to come together across disciplines, across colleges. Everyone believes in the vision, but then when you get down to the budget, it is who puts the money down. And many projects are really doomed because of that. So when I visited the University of Maine and I saw the vision and the construction of the Furlong building, because I visited it in June and then in August, close to completion. I visited the Advanced Structure and Composite Center, as well as other research labs where there were students from undergrads to PhD and post-degree working together, investing in the space so that even when teaching, they would be together. I was like, finally, there are really not many places who are willing to put money in changing the physical space to enable a vision that, even though it is shared, I think worldwide, it not always, but very so often feels like so far away that then kind of looking at just the short term prevents really then the changes to happen. So for me, I don't have enough words to say how relieved I was. I was like, even if I don't get the position, I am so happy that there is finally a university system that is willing to pick up this challenge. And everyone was saying, even if you get a job, you understand it will be extremely difficult. It was like, yeah, but finally, again. So I think when I say that the University of Maine system can really be a pathfinder nationwide, I truly believe that.
That's great. Thank you. We have had a question submitted along with renovating the spaces. Is there a plan to renovate the educational programs for the various engineering different disciplines? For example, a set of physics classes that are better suited for engineers rather than generic physics 101, 102 classes. So.
Yes. And also, what about all the math classes? And I think that, so first of all, not only it is going to happen, but these conversations are already happening. And just to give you an example, I mentioned the GEM building and how we are designing space there to enable that convergence. And actually, there are faculty from physics, mathematics, computing, and also people across the system. And we are all talking together on how we can make that happen. And that has sparkled conversations of the type, okay, so maybe, for example, in some physics classes, we could put examples that are actually in the labs and making that connection. And the same we could do for mathematics. I have taught many math classes. And what if, instead of just always like technically teaching how to do a derivative, you actually show that derivative may actually be a signal coming from an accelerometer that monitors the cardiovascular function. So it is not like we have to change all the math or we have to change all the physics. We want to teach the fundamental principles and they have to be strong, but we can still enable those connections, that are relevant to the disciplines, and we should do it from year one. So yes, it is happening.
Great. If folks are on the Zoom and have not had a chance to visit campus recently, I presume you'd welcome folks reaching out to particularly around the Furlan building and to just see what's happening currently at UMaine. Is that fair to say that you would welcome visitors?
Of course. I welcome everyone, and please do so. Come, because it is truly amazing.
That's great. So, well, Dean Guidoboni, thank you so much for taking the time to be with us. I think we're approaching the end of our hour here, and I want to thank President Fernie Mundy for joining us. Thank Grace Garland for joining in with us today, and to all of you for taking the time to learn more about the Maine College of Engineering and Computing. And we're thrilled to be able to share this with our alumni audience. So we encourage you all to keep following us on our website, umainealumni.com, not only for future webinars, but other in-person programming that we have through the Alumni Association. So thanks again to everybody, and especially to Dean Guidoboni for sharing with us today. So have a great day, everybody.
Thank you. Bye.